Yesterday we talked about one-to-one, and one-to-one means your y doesn't repeat. So looking at a graph, it passes the horizontal line test. We are concerned with one-to-one because if a function is one-to-one, then we can find an inverse. You did inverses last year in Algebra 2. So it's the same thing. We will maybe have some more ugly equations than you did in Algebra 2. Most of them are pretty basic there. But we'll have a mixture of both. So to find an inverse, all you're doing is reversing x and y. When we find it, the notation, instead of f, you put f to the negative 1, and that means inverse. So first, let's just start with something basic. If I gave you a set of ordered pairs and I wanted the inverse, all the inverse does is flips the x and y. So what would the ordered pairs in the inverse be? Not changing any signs, only flipping the order of the x and the y.
You got it right. Someone moving your trash cans.
Do we need to do b? I've got extra examples on here if we need them, but again, on b, all you would do is reverse the points. So it'd be 5, -3, 9, -2, 2, -1, so forth. Then, because the x's in the original become the y's in the inverse, the domain of the original function is equal to the range of the inverse. And the range of the original becomes the domain of the inverse. So we'll use that. On a lot of these problems, I'm going to ask you to give the domains and ranges. And you really aren't finding 4 separate things. Okay, x and y flip, so the domain and range just flip. Also, inverses are opposites of one another. They cancel each other out. So like if I said I'm going to add 5 to a number, what's the inverse of adding 5? Subtracting 5. Okay, so if my number is 7, and I do 7 plus 5 minus 5, what do we get back? 7. Right, 7 plus 5 is 12, and 12 minus 5 is 7. If I did 7 minus 5 plus 5, you get 7. So when you do both a function and its inverse, they cancel each other out, and you get what you started with. In terms of a composition, we've done g composed with f and f composed with g before. If you do both of those operations and their inverses, you will just get x back. X is what you start with. So if you do both operations, they cancel each other. So we're going to use that to check to see if some functions are inverses. All right, so the first one, I am actually telling you these are inverses, but we are going to verify it using that composition rule. It's not enough to show one way. You do have to check both because there are scenarios where one might work but the other doesn't. So we're going to do g composed with g inverse. And what should I get for my answer? X. Okay, so remember when you do these compositions, you start on the inside. So g inverse was
cube root of x.
And then you're taking that and plugging it into g. So g is whatever you plug in cubed. So if I do the cube root of x cubed, what do we get out? So that one worked. The other one. So start on the inside. G of x is x cubed. And then you plug that into g inverse. So g inverse is the cube root of whatever we plug in. And the cube root of x cubed is x. So it works. These are inverses.
Whoa, wait a minute. it's kind of like whenever we would plug like F and then G.
Mm-hmm. Let's look at another. Are you good? So if I want to know if these two things are inverses, so we start, when we do compositions, you start on the inside. G of x is so, remember when we did this, we are plugging that into f. F is 2 times whatever we plug in plus 3. And that thing I'm plugging in is the 1/2 x plus 3. So 2 times 1/2? 1. So I get x plus 3 plus 3, which is x plus 6. What does that tell me? To be inverses, both of them have to be x. If one of them is not, you don't even have to check the other. You can just say these are not inverses.
So are we just doing composites?
To check if they're inverses, yes. Alright, we'll do one more together and then I'll have you guys try one.
We're going over that one problem, right? We'll go over that problem.
Yes. Alright. So we're trying to decide if they're inverses. So we do that by finding the composition. So f of g of x. So we start on the inside. So what is g? So I'm taking that and plugging it into f. So you're going to your f and you're just going to replace that x with the 1 over x plus 1. So we get 1 over, instead of x, I have 1 over x plus 1. And then there was a minus 1.
I thought it was supposed to start with G.
We put the plus 1 was part of g. I'm taking g and putting it into f. Alright, so on the bottom of this fraction, 1 over x plus 1 minus 1 cancels. How do we divide by fractions? Multiply by the reciprocal. So this means 1 times x over 1, which is x. So that one is good. Is that enough to say they're inverses?
Yes.
No.
No.
I want to say yes.
You want to say yes. It means most likely they are, but there are scenarios where one might work and the other doesn't. So we have to go ahead and check the other. So g of f of f. Okay, so I'm going to plug in f. So that's my 1. Put f into g. So g is 1 over the thing we plug in, 1 over x minus 1. And then there's a plus 1 on the end. Okay, to divide fractions, you flip and multiply. So we get x minus 1 plus 1, which is x. So they both work, and we have inverses. Functions are opposite. They undo each other. far so good? You guys try the
The
next
next
one.
Well, I got baseball.
Let's look at this. So you could do either one first. Most people did F composed with G. Okay. So this is the same compositions we did back at the beginning of the year. You're replacing G of X with its equation. You have 1/3 X minus 4. Okay, this is going to go to F, and you are replacing that X. So we have a 3. That X is going to get replaced with the thing I plug in. So that's my negative 1/3 times X minus 4. And then plus 4.
I did that in the completely wrong way, but I got the same answer.
So we get 3 times negative 1/3 is negative 1. X minus 4 plus 4. You get negative X plus 4 plus 4. Or negative X plus 8. So right there you could stop and say, not inverses. If you work the other way, you're going to get the same thing, that they're not inverses. So if you only have to do one, but if you had started with F composed, or G composed with F, so F is 3x plus 4. If I put that into G, G is negative 1/3 times the thing I'm putting in for X minus 4. And if you look at that, 3x plus 4 minus 4, so that's just 3x, and negative 1/3 times 3x is negative x. So either way, it doesn't work, and they're not inverses.
Do we have to do both?
No, if one doesn't work, you can stop. Now, if they both do, if the first one works, you have to check the second.
I put this in the same answer.
You have the same thing I did, except you magically put it.
You must have. Growl it.
I didn't mean to put that in.
Yeah, okay, so you wrote the wrong thing here, but you actually plugged this one in.
Oh,
And then that should
I just did it wrong, but I fixed it.
Yeah. Alright, do we need another one of these guys? I'm not so sure that we're doing great with compositions. Can I add another one in?
Yes.
I think we need it.
Do it in the theorem box.
Yeah, you can add it in the margins or fit it in somewhere, I'm sure.
Margins, just doing this margins.
Alright, how about,
Do we need the theorem box? Or do you have to put stuff in there?
okay, decide if these are inverses.
It's just like that. I don't know, gosh. Black on.
I think I did it in the right way.
I'll put it in the same.
Alright, so what do you guys think?
They're inverses.
Alright, F composed with G. So G is,
X minus 3 over.
okay, you're plugging that into F. So F is 4 times whatever you plug in plus 3. So I am plugging in the x minus 3 over 4. 4's cancel, so you have x minus 3 plus 3, which is x. Is that enough? No. Do the other direction. So we have g of 4x plus 3. We're plugging that into g. So x, which is getting replaced with the 4x plus 3, minus 3 over 4. Plus 3 and minus 3 drop, so 4x divided by 4 is x, and these are inverse.
I did it in the wrong way again, but got the right thing. So I think it's just gonna work out. It's gonna be correct. It's gonna work.
You're just writing.
See, this time I put it correctly here.
Oh, but then you did
But
the
then
other one.
But it's fine.
Okay. In terms of a graph, because an inverse flips the x and y, these are actually going to be symmetric across the line y equals x. So I think when Mrs. Keller had you do inverses, she would have you graph both of them, and she usually had the line y equals x, that identity line there, and you could see it was a mirror image on both sides. So I'm just going to illustrate that with a graph here. So if I wanted to graph the line y equals 3x minus 2. Alright, we know how to graph lines. Y equals mx plus b, so we start at the y-intercept, which is negative 2. And then my slope is 3, so up 3 over 1. You could do that a couple times if you needed more points. And so then you want the line connecting those. My line is not very good. So this is my original function. Okay, if I wanted to graph the inverse, all we have to do is take these points. This is the point 0, negative 2. So what point would be on my inverse?
Negative 2, 0.
Okay, this is 1, 1. So on my inverse, it's still 1, 1. This is 2, 4. So on my inverse, that would be 4, 2. All right, so then if we graph that line, I just flipped all my ordered pairs to get points. I told you they're symmetric across the line y equals x. Y equals x is a line of slope 1, y-intercept of 0. It's the identity line. And if you drew that in the middle, you can see that that's our line of symmetry. If you fold it on that blue line, the two would overlap one another. That's a good way to check yourself. If you're looking at a graph, just kind of visualize, if I fold there, do those things really overlap?
Did you do anything to the intercept?
I just flipped it. I mean, it was 0, negative 2, so the midpoint was negative 2, 0. I didn't actually find the equation for that line. All right, so the next slide has a graph drawn. Go ahead and graph the inverse of this. And I apologize, I don't think this graph is perfectly square, so it may not look perfect when you do it, but do your best shot. So find some exact points on here and get your inverse from those. All right, so this is the point negative 2, negative 2. So when you do the inverse, does it go anywhere?
No.
Okay. This is 0, negative 1, or sorry, negative 1, 0, so it becomes 0, negative 1. Right. This is 0, 1, so that would become 1, 0. 1, 2 will go to 2, 1. So then we get that graph. If you graph the identity, it does go through the middle, so we can kind of see that our reflections across that line.
Do we have to draw the actual drawing? Just tell her.
Yeah, it's a good way to check yourself, but it's not something I would require. All right, next thing we want to go through is actually how to find an inverse. You might remember this from last year. First of all, if it's in function notation, we're going to rewrite it so it only has x's and y's. So we'll change the f of x to a y. An inverse switches the x and the y, so that's our second step, switch x and y. When we're looking at equations, we'd like them to be y equals, so we'll resolve for y. In final step, we'll do the function notation. The notation for an inverse is f to the negative 1, so we'll change that y to an f to the negative 1. So let's look at one. I want to find the inverse of this equation. So step 1, instead of f of x, I write y. Okay, second, an inverse flips the x and y. So my y becomes an x, my x becomes a y. Third, we like things to be y equals, so let's get the y by itself. So we can subtract over the 3, divide by 2, And then final step, I want to show that it's an inverse, so instead of y, we're going to write f to the negative 1 of x. No, you could have 1 half x minus 3 halves, that's also
I
fine.
did that, and I looked up and you didn't have that, and I was like, I'll
Either
just
way, it's
fix it.
fine. Okay, second thing I asked for is domain and range of the function in the inverse. So what I do is I put d for domain and a subscript of x to mean the original function. And I want the same thing for the inverse, but we know the domain of the function is equal to,
The range of the inverse.
okay, so I'm going to put r for range and f to the negative 1 for inverse. Alright, so domain of the function. Look back at your original function. We're not dividing by anything, we don't have any radicals, so what's my domain? The range of the function is equal to the,
Domain of the original, or of the inverse.
now, it's a lot harder to look at an equation and know the range, but we know this is the domain of the inverse, so I could look at my inverse. I have mine written as a fraction. We know in a fraction the bottom can't be 0. Does 2 ever equal 0?
No.
Negative infinity to positive infinity as well.
Will it always be like this?
Only if it's linear to start with. So let's look at one that's not. Alright. Okay, first step, what do we do?
Change it of x to y.
Next step,
Switch the.
switch the x and y. Because there's 2 x's, both of those get switched to a y. Now I have to solve for my y. So I'm going to multiply the denominator over. If I distribute, we get xy minus x equals 2y plus 1. Alright, both of these have a y, so I want them on the same side. I'm going to subtract over this 2y. Since this x is by itself, I'm going to add that to the other side. So I'm reordering everything with a y on one side and everything without the y on the other.
Divide by x.
This is two terms. But what do they both have?
Take out a greatest common factor.
Greatest common factor. Let's pull out that y. So then to get y by itself, we would divide by the x minus 2. So my inverse, f to the negative 1 of x, is 1 plus x over x minus 2. Then I ask for domains and ranges of everything. I know the domain of my function is equal to the, so if you look at your original function, what can x not be?
1.
So this would be negative infinity to 1, union 1 to infinity. The range of my function is the same as the domain in the inverse. So, to find it, we look at this inverse. What can x not be? 2. So this would be negative infinity to 2, union 2 to infinity. Questions on that? Are we okay to keep going and finish this up so we can do workday tomorrow? Why don't you guys try the next one on your own? Inverse, domain, and range of both. Okay. So you change your f of x to a y, switch x and y, and solve. So for your inverse, you should have x minus 2 over 4, or if you broke it apart, you could write 1/4 x minus 1/2. Is that okay? Domain of the original is the range in the inverse. If I look at the original, this is just a line. There's no fraction, no square root, so what's my domain? Okay. Range of the function is the same as the domain of the inverse. When I look at my inverse, I have a fraction, but does the bottom ever equal 0? No, so it's the same thing. I think we need to try a couple more of the fraction ones. You guys did okay with this, but let's try. I'm going to change the next example. So mark out what's there. We're just going to do, our function is x plus 3 over x. So first, f of x becomes y. Then so the x equals y plus 3 over y. We have to get rid of the fraction, so I'm going to multiply over my y. We're trying to solve for y, so we need them on the same side. So I'm going to subtract over my y. Then what would you do?
Take out the y.
Now we have y times something, so you can divide. So our inverse is 3 over x minus 1. Domain of the function is equal to the range of the inverse. The original function, what can x not be?
0.
Range of the function equals the domain of the inverse. Right. This one can't
Oh,
have
whoopsies.
equal 1.
Where's the negative one?
When you
Oh,
factored.
the negative from the thing.
All right. I've got another one. Do we need it? How are we doing?
I'm good.
Who is that first hour? It sounds like high school, is it? It sounds like third and fourth grade PE class.
Because they're freshmen.
All right.
Playing Pac-Man.
Do we need another one?
No.
Yeah, I'm good. Suppose.
Let's do the last 2 slides here. They're not going to be a lot of calculation. It's more thinking.
Oh, I'm not good at that.
Okay, so suppose f of x is the same as y, is the number of cars that can be built for x dollars. So this is telling me in my original function, my ordered pairs, the x is the dollars, And my f of x or my y was number of cars. So think about what you know about inverses. What would the ordered pairs in the inverse represent?
Number of cars to dollars.
So I want a sentence for what f inverse of 1,000 represents.
Build 12,000 cars for X dollars.
So the 1,000 is the x value of the inverse, which is the number of cars. This whole thing represents the y in the inverse, which is the dollars. So this is the total cost or dollars, whatever you want to put. To build 1,000 cars. That's it. I just wanted the sentence. What is that? Is that all right?
Sure.
Final thing I want to look at is a graph. I want everybody paying attention here. So, on this graph, this is the original function. But I'm asking you questions about the inverse. So when we look, the 2 of the inverse, what was that on the original? The y. So on the original function, it's like saying, well, the y is 2, tell me what x was. So if I look at this graph, when we had a y value of 2, the x value was 0. Take a second and see if you can do B and C before I go through. Bless you. Is the whole school having problems with Wi-Fi, or is it my room?
It's not just your room.
No, it's not.
Miss Roberson's room does it too.
It's getting really frustrating.
Let's see, every classroom.
I mean, yesterday even my desktop wouldn't work.
And that's connected to the internet. It's not even,
Not even
The
just
router.
Wi-Fi. Okay. So, B is like saying if on the original graph, the 3 would be the y on the original graph. Tell me what the x is. So when my y is 3, what was the x value? 7. And f inverse of 9 means tell me the x when the y is 9. And that is also 9. Are those okay? All right, so the assignment is Math Excel. We will have a work day tomorrow, and that assignment will be due on Monday.